When it comes to the types of data structure, you all know that we have two things. One is primitive data structure, another one is non-primitive data structure. I can make the linked list with the help of the arrays. Array index will always starts from 0. And circular linked list, that can be a single circular linked list or it can be a doubly circular linked list. Hello everyone, I welcome all of you to the yet another interesting session on the basic concepts of data structure. All of you would have seen my first session in which I have discussed the basic definition, what exactly the data structure is all about, and I have also introduced to the different types of data structure. Yes, without wasting much of your time, it is time for all of us to understand and to know what exactly I have in this session for all of you. Let's check that. In this agenda, I will be discussing one of the important thing. So that's going to be the non-primitive data structure. So are you going to complete the entire non-primitive data structure today? No. So especially in this topic, I will be discussing or I will introduce two concepts. That's going to be the arrays and linked lists to all of you. So guys, without wasting much of your time again, let me get into the topic. So before I start what exactly arrays and linked list, so let me show you once again what is that we are trying to do. So we have discussed these concepts in my previous session. So this is what I will call it as a types of data structure. When it comes to the types of data structure, you all know that we have two things. One is primitive data structure, another one is non-primitive data structure. So we have discussed in detail about the primitive data structure. What is that you have to remember? You just have to remember one important thing. If I want to store a single value, so I will be using the primitive data structure. And you all know what is integer, float, character, pointer. But now it's time for us to understand the non-primitive data structure. In this session, I will be discussing mainly about arrays. Sir, are you going to discuss in depth about arrays? I'm not going to discuss in depth about arrays in this session. I will just introduce the topic to all of you. Along with the arrays, I will also introduce a topic called linked list. Once I'm done with the explanation for all this topic, my dear students, according to the syllabus, I will start explaining all these topics in detail. So you don't have to worry. Say for example, most of you will think that, once I'm done with the array explanation, once I introduce you all to the arrays, is that enough, sir? Is that you're going to do? No. I will be explaining, I will be speaking about this arrays in depth in the coming sessions. So what is that I'm trying to do here? I'm just trying to introduce these concepts to all of you. So to complete the types of data structure, that is what I'm trying to do. All right. Let's get into the session without wasting your time. So the first topic which I'm going to discuss with all of you in the non-primitive data structure is all about arrays. Sir, before that, could you please tell us again, why are you calling that as a non-primitive data structure? My dear students, suppose if I want to store, say for example, here I have a is equal to 10. So how many values I'm trying to store in the variable? 1. If I want to store more than one value, say for example, I want to store 10, 20. How many values I have here? I have 2 values, correct? So when I have 2 values, I need to store these 2 values. So what is the problem for you? You can store it, right? So you can store it like this, a is equal to 10 and b is equal to 20. What is your problem? My problem is I want only one variable. Here I have taken 2 variables. I have taken a and I have taken b. But I want to take only one variable. That's a problem here. So how do I store it? So I can store it like this. A is equal to, 10, 20. So I'm using a concept called arrays. So if I'm storing more than one value in one variable, such data structures, I will call it as non-primitive data structures. When it comes to the concept of non-primitive data structure, we have n number of data structure. That's what we are trying to understand one by one. So the first one which I'm going to start with is arrays. Let's start what exactly arrays is all about. Array is a beautiful Hindi word to call a person who is sitting there. Hey array, idhar dekho. Is that? No, right? So my dear students, arrays, in the sense, you will be storing homogeneous data. The first thing that you need to remember is you will be storing homogeneous data. Sir, what is the meaning of homogeneous data? Homogeneous in the sense what? Same type of data. So first thing, so I will be storing same type of data. That is the first thing that you need to understand. So fine, I understood that I will be storing the same type of data, and it is a collection of data. Collection of data in the sense what? So you will be storing more than one data. You'll be storing what? More than one data. And my dear students, you need to remember one more important point. So it is a continuous allocation of memory. Continuous allocation of memory in the sense what, sir? So we understood that if you are storing the data, it should be of same type. I cannot have here integer, and here I cannot have no float 7.5. I cannot have that. If you are storing integer, you should store only integer. If you are storing float, you should store only float. If you are storing character, you should store only character. That's the condition of arrays. That's the first condition of array. So fine. Second condition, continuous allocation of memory. What is the meaning of continuous allocation of memory? Say for example, I have allocated the memory to store the 4 here. I'm storing the 4 here. Here I cannot leave it empty and I cannot store 5 here. Continuously you have to allocate. That is what we call it as a continuous allocation of memory. That is the second important point that you should remember. So fine, I understood that same data type, all the data elements, whatever you are trying to store, it should be of same type. And then, my dear students, you need to remember it is a continuous allocation of memory. And again, I will have a question. Sir, I am storing multiple data elements. Say for example, I have 4, 7, 5, 45, 11. So I have a number of elements here. Suppose if I want to access this particular element, how do I access? So for that, remember, the array will have something called index. Array will have something called index. Each data item is indicated or will have the index. So that's what you need to understand. And one more important point, always the index starts from 0. So you should not write, always it starts from 1. Okay, always whenever I say about array, always you need to understand array index will always starts from 0. That is what you need to remember. So fine, sir, I need to access this 11. How do you access? So if I want to access this 11, so first of all, you need to remember each array will have the array name. Let me take the array name as A. What is the name of the array? Array name is A. Suppose if I want to access this element, okay, how do I access? If I write A of, what is the index for this element 11? So it is 4. If I write A of 4, I will be able to access this element. This is what you need to understand with respect to the array. So this is the basic information that you need to understand with respect to the arrays. One more important point that you need to observe here is it's a linear data structure. What is that? It's a linear data structure. Sir, what is the meaning of linear data structure? You are storing the data one by one sequentially. So that is what we call it as a linear. So when it comes to the concept of array, arrays is a linear data structure. So that is what you need to remember. Whenever I say linear, so you should understand that sequentially you are storing the data one after the other. That is what I will call it as a linear. So hope you understood the basic concepts of arrays now. Alright. So sir, is this enough if I understand about arrays? No. I will be speaking in depth about arrays, different types of arrays, what is the operations that I can do on arrays in the coming sessions when I'm starting the concept of arrays. Mainly I will be discussing about arrays in a separate session in the coming session. So there I will be speaking about the complete applications, the operations and the implementations of arrays. Okay, don't be bothered about it because I'm just introducing this topic. So that's it. I'm not discussing here in depth. In the coming session, I will be speaking about this arrays in depth. I'm just following the syllabus. Even you also please follow the syllabus. Moving forward to the next one. I discussed about the arrays. The next concept here I have is all about the linked list. When it comes to the concept of linked list is one of the data structure that we have. This linked list can be implemented with the concept of arrays. Sir, what is the meaning of it? Just imagine I have a cloth, okay? I have a piece of cloth. In that piece of cloth, I can stitch shirt, I can stitch pant. Of course, I can stitch pant, right? If I have enough cloth. So there is no constraint, right? So, but cloth is very important, right? So in the same way, arrays is like a cloth, okay? I can stitch, what is that? I can stitch the linked list, or I can stitch anything, whatever I want. So that's what you need to remember. So now, this linked list is a pant, okay? Arrays is a cloth. That's what you need to remember. I can make the linked list with the help of the arrays. So then you will tell me what type of data structure the linked list comes to the category. So obviously it's going to be the linear data structure, right? Yes. Let's understand what exactly linked list is all about. Whenever I say linked list, one thing it should come to your mind. What is that? Train, sir. What is that you will come across? Train, okay? So let me just write a beautiful diagram for all of you. So you have to tell me, okay? Okay, so this is a bogie. Okay, one more I will write. So, there'll be smoke which is going. Okay, so this is a wheel. Okay, this is a connection. All right, so beautifully I have written the train for all of you. So this is where loco pilot will sit. Okay, you want the 3D diagram? Oh, I'm sorry, I'm not so very good in writing the diagrams. So this diagram, this beautiful diagram should come to your mind whenever I speak about the linked list. Sir, how it is related, this train and this linked list? My dear students, you just need to remember this diagram. Sir, why should we remember this? If you ask me, so whenever I say linked list, a very important word or the term that you should remember, that's going to be the node. What is that you will remember? Node. What is this node? So node contains two parts. It's a basic unit of a linked list. It contains two parts. So like this is a node. Okay. So one part stores the data item. One part stores the data item. The next part, whatever I have, this part stores the address of the next node. Address of the next node. So this is what you need to remember. So what you will remember? So you will remember about the node. You will remember about the node. How many parts I have in this node? My dear students, I have two parts. Okay. So what is that you are going to have in the first part? You are going to have the address. Is it? No. You will have the data in the first part. In the next part, you will have the address of the next node. This is what you need to remember whenever you remember the concept of linked list. So let's understand in depth now what is linked list. A linked list is a linear data structure. Observe, a linked list is a linear data structure. What is the meaning of linear data structure? You will be storing the data sequentially, one by one. That is the meaning of linear data structure, like arrays. How do we store an arrays? One by one. So in the same way, even in the linked list also, we store the data in a linear fashion sequentially. That's what you need to remember. So fine, where each element is separate object. So this itself is a separate object. So this is what you need to remember. This is separate object. This is separate object. Like this, you can have n number of separate object is what they are trying to explain. Each element, that is node. So this is what I will call it as a node. This is what I will call it as a node. That's what you need to remember. Of list comprising two items which we have already discussed. So one is data, another one is the reference of next node. So this is what the basic knowledge that you should have with respect to the linked list. So I will show you some diagram to remember this. Before that, how many types of linked list I have? So I have, my dear students, remember I have singly linked list and also I have doubly linked list. One more linked list that I have, that's going to be the circular linked list. Okay, so I'll show you each linked list with an example so that you will be able to understand it very quickly. So observe this. What is that I have? So guys, this is what I will call it as a node. This is what I will call it as a node. So please observe, what is that I have? What do you call this 12 as? You will call this 12 as data. Okay, you will call this 12 as data. Okay, so what is this? This is the address of next node. This is the address of next node. So this is what you need to understand. So here, if I come, okay, this is the data and this is the address of the next node. So guys, at the end, I will have null. At the end, I will have null. So this is what I will call it as a singly linked list. So this is what I will call it as a singly linked list. So you will be traversing in one direction. You will visit this item, then after that this, after that this. So you will be traversing in a one direction. That's why I will call it as a singly linked list. So hope you understood what is singly linked list. Linked list in the sense what you will remember? You will just remember the node. So in that node, how many parts? Two. One is data, another one is address. Address contains what? So address of the next node. The last node address will be null. So that's what you need to remember with respect to the singly linked list. Fine. Moving forward to the doubly linked list. When it comes to the doubly linked list, so please observe this diagram. So what is this? My dear students, what is this? Please remember, what is this? This is the node. Observe, this is a node. Sir, but we don't have two parts as you said in the note. We have three parts. So what is this and what is this? So observe now carefully. The center part I use to store the data. My data is in the center part. Can you guess what is that I have here and what is that I have here? What do I store? Okay, can you guess? Anybody? So yes, of course, your guess is correct. So I will store the address here. What address? The next node. I will store the address of the next node. Here, what is that I will store? The address of the previous node. That's what you need to remember. Please observe here I have given. Okay. So what is that you will store? So you will store the address of the next node. So what is that you will store here? Address of the previous node. And here you will be storing the data. Sir, why do we need the address of the next node and the previous node? So when we had the singly linked list, was it not enough? So observe the drawback here. I can traverse only in this direction. I cannot come back. That is my drawback here in the singly linked list. But I have the address of both next and the previous. So which will help me to traverse in both the direction. So that's the advantage that I have in the doubly linked list is what you need to remember. And the next one that I have is circular linked list. My dear students, it's very, very simple. Observe here. Usually you all know that when it comes to the circular linked list, so the last node reference part contains null. But here it is not like that. The last node will not contain null. Instead, it contains the address of the first node. Address of the first node. So it forms a circle. Hope you understood. I repeat. Observe here. So what is that you have in the last node address part, that is in the reference part? So I have the null. Null in the sense it does not point to anything. But I will remove this null and I will place the address of this node. What happens? So it will start pointing to this. So then this singly linked list will become circular linked list. It will form a circle and it will become circular linked list. So hope you understood the concept of circular linked list. Okay. So let's check out the points with respect to the circular linked list. So quickly, circular linked list is a linked list where all the nodes are connected to form a circle. Yes, of course, we know that. So there is no null. Yes, we don't have null in the last node. That's a main point that you need to remember. And circular linked list, that can be a single circular linked list or it can be a doubly circular linked list. So I can make the circular linked list with both the linked list. That's going to be the singly linked list or doubly linked list. That's what you need to remember as of now. So we have understood, we have discussed the concept of what is arrays and what is linked list. How many types of linked list we have? We have 3 types of linked list. One is single, double, and circular. So hope you have the brief knowledge what is about array and what is about linked list by now. Alright, so don't think that this is enough for your exam and in the syllabus. I will be discussing in detail in the coming session. I'm just trying to introduce the basic concepts before I get into that concept in depth. Alright, so by saying this, I've come to an end of this session. So keep waiting for my next session. I will help you with different non-primitive data structures to understand it in a better way. So thank you. Bye-bye.